I'm Ed, and this is my light show here at the Maturango Museum. I'll go ahead and give you guys a brief tour to show what all the lights are, how they're set up, how everything works, so you guys can get an idea of how this whole thing operates. Okay, so the basic starting point for the actual light show, and we'll be able to control all these lights, goes to basically the brain of the entire show, which happens to be a small little microcomputer, which is inside this one box right here. So what we have here is, this is a Raspberry Pi. It's a small microcomputer running a version of Linux. There's a thumb drive on here that has all of the sequence files and music files on there. There's a network cable that goes to a small Ethernet switch. There's an audio cable that comes out of the Raspberry Pi and goes over to an FM radio transmitter. Off of the transmitter, there's a small FM dipole antenna made out of simple coax wire that wraps around the inside of the case. So I transmit an FM signal for the audio that goes into the sound system. And I have a Wi-Fi dongle on here, so that way I can go ahead and get this on the main Wi-Fi network. Because I have this, I can actually control the actual light show using my laptop computer or my phone. So for example, when I was outside directing traffic, I was actually able to start a intro sequence from my phone, even when I was outside, in order to get the show started. The rest of this is just power. So Ethernet signal comes out, goes into the Ethernet switch, and then all of my other controllers comes in through my Ethernet network. This is a separated network infrastructure, so that way all of the network traffic that goes to the controllers is separated, so it doesn't bombard a Wi-Fi network at all. It has I'm using a 10.0.1 network IP addresses for my intercommunications between all the controllers. So that is the brain of the show. The next part here, I'll go ahead and show you, is another control box. This one actually controls the icicle lights. So inside each of these we have a power supply, and then you have the actual controller sitting up on top. So here's the controller, here's my Ethernet cable that goes back down to the brain computer. So this one right here goes to my actual light pipes, and then this one right here, these three goes to the ceiling for the icicles, and then I had to use the other half of this controller for the bottom part of the matrix display. The matrix display here that we see during the show, there's basically these strands of lights that goes all the way across this. This is a PVC frame that's with the lights. There's actually there's a mesh netting that's actually on here. So these the light strings start on this side and goes to the right side. These have these cables with the waterproof pigtail connections that comes down into another controller right here, similar to the one I just showed you. This is 48 pixels down and then 22 pixels for the up and down. The controller for this is the primary controller for the matrix display, but this still only covers the first 16 sections of the matrix display. The other remaining 6 are coming off of the other controller that's over here. Now, because I'm using one entire element across 2 separate controllers, I was forced to use multicast because I didn't figure out the math to do unicast for the universes, because I'm actually splitting the actual DMX universes between them. So I was only able to get part of it, or I would have a block that would be missing. So instead of going back and doing the math, I just decided to go with multicast, which seemed to work out just fine with this particular setup. Okay, the other 2 controllers that I just showed you, those were SAN devices, E682 controllers. There's one more controller that I'm actually using for pixels. Here's another control box. This one's a little bit different. This one is called an Alpha Pix 4. Here's the power supply. This one's kind of nice because it has a screen on here, so I can actually configure the IP address directly on the actual unit right here. Here's our Ethernet connection. This has 4 dedicated outputs. The E682s have 16. This only has 4. And each section has a fuse for that, so I have a connection that comes off and goes to the actual pixels themselves. Now, what's interesting about this particular controller is it also has DMX output. What that means is I can have other elements coming off of this particular controller that are not standard pixels. So I'm going to go ahead and show you the next controller that actually comes off of this, but this is DMX output, and so this runs my Light-O-Rama controllers as well as my floodlights for some of the other various effects. I'm going to go ahead and start showing you guys the props after I show you guys the Light-O-Rama controller. Now, most of the elements that you see in the show are actually DC powered LED lights. These ones are actually a little bit different. These are actually AC powered, and so they come off of a different type of controller. They're called a Light-O-Rama controller, and it basically has 16 different channels that has controlled by a triac, so I can turn on and off and ramp up and down the AC power that goes to standard Christmas lights for this particular element. This is my singing quartet, and so I have 8 channels per to make the actual mouth movements and the eyes, for example, and that all comes from a different controller which I have hidden underneath here. This is the Light-O-Rama controller. So here's a connection right here that basically daisy chains between them. I have 2 more of these behind the actual quartet to be able to handle all the vocal parts of the characters. And then this control signal goes back to that other controller, the Alpha Pix 4. So I have all of my Light-O-Rama controllers running off of a DMX mode. So that way everything basically comes off of the Raspberry Pi and goes through Ethernet connections, so that way everything is much easier and cleaner to program and to set up. So here's a better view of my singing quartet, and then on the back side of the actual quartet I have I covered everything in a black sheet, so that way I'll have less light splash. But what we have hidden underneath here is the other controllers. So I have 2 of these more Light-O-Rama controller boxes for controlling the quartet. For the other elements, here are my pixel pipes. My initial intention was to have these going across a grass line, but I can't stake the pipes down into carpet, so I built a simple test jig out of a 1/2-inch PVC pipe. These pipes are actually 1-inch PVC, and then there's 5 pixels in each one. So 4 on the side with using a pixel strip. So I had to cut the side, put the LEDs on there, glue it into place, and then I have the top piece. It's a standard cap. I cut the top off and flattened it out, so that way when I turn the top one on, the light actually gets partially reflected and gets just a little bit more emphasis on this actual light. So like strobe effects going across the tops, for example, and it looks really, really nice. Because I'm using the 1-inch PVC, the 1/2-inch just slides right in pretty easily. So, and I can easily just get the cheap 1/2-inch PVC pipe, and I just extended it out. I did have to cover the PVC pipe in electrical tape. I just bought some in bulk. It was like $6 for a 10-pack. That way, during the actual show, the pipes are not as noticeable. Also, because of the height of the pipes, the actual matrix display I had to raise up. It's actually 18 inches off the ground. If it went any higher than that, then the whole matrix would kind of destabilize and it wouldn't really stand on its own. It would need additional guide wires and supports. But so in an indoor environment like this, it's perfect. Now I do have just a few AC elements. This is a Mr. Christmas light projector, and so I have this hooked up to the Light-O-Rama control box. Another element I have hooked up to the Light-O-Rama control box is a bubble machine and a fan that I have set up. It's already turned into the on position, so as soon as I turn it on for the Light-O-Rama controller, I cannot ramp it. It's just an on or off. It will start the bubble machine and the fan, and the fan will actually create an air duct channel through the room to basically push the bubbles right where I want it. If I didn't do that, then the bubbles would only come out about, say, 6 or 7 feet in front of the bubble machine, and it wouldn't carry all the way across the room. The fan helps create a Venturi effect to help carry the bubbles further across the room to make it rain down on the kids for a nice snowfall effect. So that's a better view of the pipes here. This is a little special here. This is my light pipe organ. So there's pixels down inside each one of these, and so it just kind of daisy chains back and forth between these. Just a bunch of PVC pipe that I use just kind of create a unique musical instrument out of light. Now up here I have my icicle pixel lights, and I'll go ahead and show you that. Okay, these are my icicle pixels. Pixel icicles. So basically it's a section of coat hanger wire with these actual pixels just bound to them. So you can see it's basically just zip tied on there. You can see the actual control wire that goes between these. And so I have the actual control line, so it carries the data and the power between each section. So it's roughly 2.5 feet of cable between each one. So the way that the way this actually works is the signals, it all gets hooked back up to the controller that was back down underneath the matrix display. So the wire comes back up here behind the projection screen and connects into this first one, and then it goes all the way down. So I have basically 10 of these. So it comes over here, zigs over, and then carries all the way back for each section. And I have 3 sections, so that's a total of 30 of these icicle pixel lights to create the snowfall effect. I had to turn off the fan for this, and also because of the bubble machine, just as a precaution, I also disconnected the projector that's in this room and bagged it so that way none of the bubbles would actually get into it. And then for the last part of this is I added a simple LED spotlight. The reason for this is when the bubble machine kicks on and the light goes and the room goes dark, it makes a really interesting effect when I light the bubbles from this LED spotlight. It really makes it stand out and shine for that effect, especially when it gets brought out to the audience. Now, the other interesting part during experimentation is that bubble machine is obviously mounted on top of a ladder with the fan, and I tried it in various locations. This seems to work out the best. The reason why is because with this fan operating in a reverse direction, so the air is going up and then spreading out from the top instead of pushing it directly down. What that does is it helps bring the bubbles from here across the entire room. So that way it actually reaches all the way out here where the kids mostly are sitting, and so the kids basically go completely nuts as soon as the bubbles kick in. Then they really have a memorable experience. To give you an idea of the type of coverage for this particular type of bubble machine and how it fills the room. Now, with a bubble machine like this running, there has to be some careful consideration made. This is a carpeted environment. When I did some testing on the bubble machine inside my house with tile flooring, after about 30 seconds, it created a bubble layer, a film of soap on the tile, and almost injured myself in the process trying to shut the thing off just because of how slick everything got. So because of the wider area like this with the fan running, it's not as big of a problem, but usually don't want to go past about, say 20 or 30 seconds in an environment like this, because I don't want to get too much bubbles solution throughout the carpet or anything. The floodlights, these are halogen based, these are halogen basically containers, and there's a DMX controller inside each one, and it goes back to the controller systems as well, so I can address each individual floodlight, and this has basically just dumb LED lights in them that goes into the DMX decoder, and then it runs off of standard 12 volts. So that way I can use basically a fill light on the back end of the room to generate other effects as well. Now, the physical elements of the show are only half the story. The other half of the story is the actual sequencing that actually goes into each song. Basically, it's anywhere from 4 to 10 hours of sequencing per minute of song, depending on how complex it is. The reason why is because as as good as the Quartet looks, that's because of hours and hours of work to get the vocals to look as accurate as they are. And then the other auxiliary effects, plus the setup, plus the prop building, so it easily pushes into multiple hours per minute of actual show sequencing to get everything going. The program I use is called xLights. This is my my show computer laptop that I'm utilizing. Now, because of the Raspberry Pi in control box, what I can actually do is I can actually control the entire sequence, the entire show from a web interface. This is actually how I'm running the actual show. So here's the playlist, and here's the songs that I actually ran for this particular show. Here is xLights. Now, someone was actually asking me and trying to understand how this whole setup actually works, and wanted to go ahead and just very quickly illustrate. The physical props, each light is individually controllable. However, it's a matter of how you actually represent them into what's called a model. So these are all of my models that I actually have that I apply effects to. So, for example, this is a spinning swirl effect, and right now you can see that the spinning swirl effect is actually being applied to my pipes right there. And I can also preview it on the laptop right there, so you can actually see the effect. Now, the way that that's actually being addressed, I can actually show you when you actually look at the actual models. So, for example, here is my grass pipes. Here are the actual pixels that I'm actually controlling with those. So I'm only doing layer 1, so basically the first pixel on every pipe is being controlled right now for this particular effect, and this is the model that it's being applied to. So what I also do is I redo that particular model, and like say I have grass pipes all. So now here's every address. So basically this looks like a CSV file, like an Excel spreadsheet file. So start with 1, 2, 3, 4, 5, and then the next row over 6, 7, 8, 9, 10. And so you create this two-dimensional CSV file for a custom setup, and then I apply the effect across this. So there are various effects where, for example, the snowfall effect, that's being applied to all of them, but other effects where I'm having a pattern like burst forwards towards the audience, it looks a little bit different, and you basically have to kind of visualize it a little bit differently in order to make that effect work. This is obviously not coming towards the audience. This is looking up and down. So for this particular spinning effect, I'm actually looking at the actual field of lights from a two-dimensional view, looking downwards on them and applying that particular effect. Now, if I look at them in this way, using all, this is looking at them from straight on as the audience would see that. So if I did an effect like this, it would actually splatter up, and it would look like it's actually advancing back because of the way I have it represented on here, versus two-dimensional just looking straight down on it. And I have the same type of setup for the ceiling lights as well. Here is layer 1 of my ceiling lights, for example, versus I also have ceiling lights full, where I have all of them. So I can basically do the exact same principle for that. So the snowfall effect right now is being applied to the ceiling full, so that way you get that particular effect. It generates the snowfall effect. It wants to come straight down each particular section, and that's how that is represented. Now, the pixels are more difficult to kind of visualize and understand. The other elements, for example, the singing quartet, this is a bit easier to really understand. Here's the layout for this, that you can see what this looks like. Now, these are not pixels though, but what I do have is I have 8 channels per, and so you have the outline. Here's the eyes open, here's the base of the eyes, here's the upper lip, middle lip, lower lip, and then I have a circle, and then I have an oval for those particular channels. Now what I also do is I can also name them, so that way it makes it a little bit easier to figure out which one's which. And then I create a faces definition, so basically the particular software I have, I can create an audio track with the vocals for the actual words that are actually in the song, and then in order to make a particular word, there's certain what's called phonemes, and there's actually a dictionary that's built in, so it translates the words that I have selected into the phonemes, phenoms, not sure exactly how you pronounce it, but so an A, an E, a T, an F, an L, for example. So a combination of those, using these different channels, turning them on and off, creates the effect to make it look like the characters are actually singing the actual song. And then here is the bubble machine that I'm using. So you can see the Venturi effect. What it's doing is it creates that channel and it blasts it all the way out, so you can see the bubbles actually carries way out here before they actually start settling downwards. And then the actual fan helps to kind of suspend the bubbles in the air, so I have a bit of a longer hang time effect for this. So, but this particular set seems to work out pretty well. Okay, well, I hope you enjoyed the behind-the-scenes tour. If you have any questions or comments, go ahead and post down below on this YouTube video, and I'll try to respond as quickly as possible. I also do have a blog for various elements that I have actually built out, and how-to guides and whatnot. So I'll probably be posting various links as well, so you guys can see how certain these elements are actually put together. For example, the pixel pipes, as well as a couple other things. Anyways, like I said, just click down below and go ahead and create a comment, and I'll go ahead and respond. Thanks.